Everybody makes mistakes.
Like I was saying, everybody makes mistakes. And sometimes we're not even aware that we're making mistakes.
But other times, we might feel as if a mistake is about to happen before it actually does.
Becoming aware of our errors is pretty important. Without the ability to know our errors and learn from our mistakes, we'd hurt ourselves and others over and over, even more than some might say we already do. So, my thesis was about how we become aware of our errors. What's going on in the brain that makes us feel like something went wrong? What specific neural processes lead to error awareness? And before I try answering that question, just know I'm going to briefly mention a lot of different things, and if you want more details about any of them, use the links in the description.
In the early 90s, neuroscientists discovered an ERP that happens on the average of trials where subjects failed to follow the instructions of the experiment, or in other words, they made a mistake. This negative deflection on frontocentral electrodes was named the error-related negativity, or ERN for short, and it happens around the same time that an error happens. There's a lot of evidence that the ERN comes from a place just underneath the PFC called the anterior cingulate cortex, or ACC for short. So the ACC emits a signal that's picked up on EEGs, and it's called the ERN, but what is that signal actually doing? The leading theories of the ERN can be divided into two general categories: comparator theories and conflict theories. In comparator theories, the ACC is responsible for comparing the actual response to the intended response, and when these two don't match, it signals the other parts of the brain that an error occurs, and we see this signal as the ERN. Conflict theories of the ERN view the ACC as comparing many competing signals, not just from right and wrong responses. In this view, the ERN represents how much these competing signals conflict, and so all actions have some level of conflict, but an error is just some high point on this continuum of conflict. In fact, an ERN-like waveform can even happen on correct trials, and this is called the correct response negativity, or CRN for short, which suggests that the ERN isn't specific to errors per se, but conflict more generally.
That's all great and interesting, but it doesn't answer my question. Of course, anything that can detect errors, by definition, has to be able to compute that an error occurred. But it's not obvious why that computation has a subjective experience. So think of it this way. Cars can detect certain kinds of errors, and when they do, they turn the check engine light on. But most people don't think that the car had a subjective experience of its error. So what I want to know is if the ERN reflects conscious error awareness, or is it part of the brain's subliminal error computation? Some studies of the ERN and error awareness find that the ERN amplitude increases, which means it gets more negative, with increasing error awareness. And they take this to mean that the ERN reflects a conscious process of feeling a mistake. But other studies completely disassociate the two, saying that error awareness can happen without an ERN, or an ERN can happen without any error awareness.
A review of these studies gave three kinds of explanations for why the results are so contradictory. One, they're different, and by that I mean the experiments use different tasks, so maybe the different tasks lead to different kinds of error processing. Two, the stimuli in these different tasks are not the same. For example, maybe they're more or less perceptible, or there's a lot of stimuli that are really different from each other, whereas others use less stimuli that are more congruent and harder to tell apart. And three, how researchers measure awareness is different. For example, some experiments ask participants to rate their accuracy on every single trial, whereas others ask participants to mark only the trials that they think they got wrong.
On that last point, I think that ERN researchers of error awareness can learn something from the larger paradigm of the neurocorrelates of consciousness, or NCC for short. So recent NCC research suggests that If you record people's brain activity and ask them to report their experience, then what you record is more than just the experience itself. It's also all the processes that make it possible to produce a report, like selective attention and expectation, reasoning and planning, and you get the point. Just relying on people's reports of their experience makes it impossible to disentangle the brain activity of the experience itself from all the processes that come before, after, or even during the experience that make it possible to produce a report. Another recent study from a group of ERN researchers found that people can often become aware of their mistake just before it happens. So these early error sensations might be a problem for theories of the ERN, especially to those who think that the ERN reflects a conscious process. Because how can people become aware of their errors before the ERN should happen? So here's what we did. We got some volunteers to play a little game while recording their EEG. And here's how the game worked.
At the start, they were told to press the left arrow key if the target image was facing to the left, and the right arrow key if the target image was facing to the right. Then, subjects were briefly shown 12 images, one of which could be the target, and another could be a difficult distractor that was similar to the target but not identical. This repeated 30 times per block. Each block had a chance associated with it that a performance-related question might appear after any given trial. The question asked them to rate how they performed, and there were 5 response options, ranging from sure incorrect to don't know to sure correct. So some blocks had a 0% chance of questions occurring, which means no questions at all, just the game. Others had a 100% chance, which means they rated their performance after every single trial, and the rest of the blocks had somewhere in between. If they ever used the incorrect options, then a follow-up question appeared, asking them to estimate when they subjectively sensed that an error occurred in relation to the action that they marked as incorrect. One last thing. I needed participants to make a lot of errors, so when they were doing too well, then on the next block, the stimulus was shown for less time. But I didn't want them to outright fail just because it got too hard. So if they started to perform too horribly, I returned the stimulus duration back to its original length. Here's what I found. First, ignoring how the participants subjectively felt they did, and just by looking at objectively correct and incorrect responses, there is a significant difference between the ERN and CRN. When I compared the ERN across short and long stimulus durations, whether the target and difficult distractor were the same color or different colors, and the percent chances that determined if they were asked more or less times to rate their own accuracy, there were no significant differences. But what about error awareness? What about the subjective ratings of the volunteers' performances? When I separated the ERN and CRN by subjects' responses to rate how they did, I found a clear visual result. When subjects thought they had made an error, the waveform around their response became more negative, regardless of whether they responded objectively correct or not. Here, unaware error means they objectively made an error, but rated their response as correct. And an aware error means that they got it wrong and labeled it incorrect. Similarly, aware correct means they both responded correctly and rated their response as correct. But unaware correct means they responded correctly and then rated their responses incorrect. Statistically, there is a significant difference between the CRNs, but not the ERNs. I also wanted to apply the lesson from NCC research that making people report their own experience can interfere with the brain activity that then gets interpreted as the minimum and sufficient neural mechanisms to support a particular experience. So, I subtracted the unaware error ERN from the aware error ERN and compared this aware-unaware difference across some of the different chances that performance-related questions might be asked. The largest aware-unaware difference came from the blocks that had questions after every single trial, the 100% chance condition. This difference was numerically larger than all other conditions, and it was significantly larger than the 10% chance, but not the 50% chance conditions. Lastly, I also separated the ERNs by subjects' responses to when they sensed an error occurred. When people said that they experienced an error at the same time as committing the error, which is the blue line, or they realized their mistake sometime after, yellow line, those ERNs look pretty similar. The waveform from trials where subjects reported an early error sensation stands out. It almost looks like the ERN happens before the other two, but it also looks like it could be random noise. And none of these were significantly different from one another. Now, there are some important limitations to this experiment. First, only 10 people participated, which leads to low statistical power, which means there was a high chance of getting false negatives. We wanted to test more subjects, but the world had other ideas. Second, because this was a novel experiment, being a first of its kind makes it impossible to determine whether the results were due to the specific features of this experiment. That said, here's what I learned.
It's possible that the ERN reflects both the exact moment we become aware of our errors and how strongly we feel that moment. But it's also possible that when the ERN co-varies with error awareness, it's not because it supports conscious errors, but instead because it supports a subliminal computation. In this experiment, I tested stimulus perceptibility and color congruence, but there are a ton of other factors that could explain the differences between these kinds of studies. For example, I didn't look at the effects of task demands or motivational influences, or what the appropriate kind of post-error behavioral correction was. But what I found most interesting was that blocks with the highest number of performance-related questions gave the biggest difference between aware and unaware condition ERNs. That suggests that how awareness is measured affects the ERN across aware and unaware errors. And if that's true, then the standard ways to assess error awareness could influence the difference across these waveforms. And that means if ERN researchers are interested in studying conscious error processing by using performance-related questions, they might find themselves in a catch-22. And here's the catch. Just asking for awareness obscures the true relationship between the ERN and error awareness, which conforms to claims from NCC research.
Report-based confounds can conceal the neural correlates of conscious content. Thank you.